We're looking at these vector notes. And so the first thing I want you guys to remember is the 4 different quadrants of our graph. So if you're looking at XY graph, you should remember that in the first quadrant, so way over here, from 0 to 90 degrees, we have positive values in the X direction and in the Y direction. In the second quadrant, from 90 to 180 degrees, you should remember that we have positive Y values, but our X is negative because we're on that left side of the Y axis, which means our X is negative. In quadrant 3, we have negatives for both X and Y. And then in quadrant 4, we have a positive X and a negative Y. Hopefully you guys remember that from math class because that's going to be super important when we're doing vectors now and when we're doing forces in the future where you're drawing these vectors. So when I say vectors, what I'm really talking about is something that has a magnitude and a direction. So anything that goes in both magnitude and direction, we quantify as a vector. A scalar would be if we just gave you a magnitude. So if we're thinking about this in things we already know, vectors are things like velocity that tells you which way you're going and how fast you're doing that in. Speed would be our scalar quantity or something that just gives you the magnitude. It doesn't care what direction you're going. So our vectors are going to be drawn on our graph just like this one over here. So we would draw it as an arrow showing that vector A right here has a magnitude of 14 newtons. Newtons is a unit for force, which we'll quantify later when we get further into forces next week. But this is our magnitude or our value, how large our force is. And then we're given a direction. So this is our direction, which way we're going. So vectors mean magnitude and direction are given, which is why we have an angle and a value for that arrow or an amount of force. So what we're going to be doing throughout this week is going to be figuring out the resultant vectors. So figuring out the parts for the X and the part for the Y. So we are going to draw some triangles. You guys have already been doing this with one distance. So we've already been doing this a little bit, especially when we talked about our kinematics and we were drawing those velocity vectors. When we were drawing them in both the X and Y direction, we're doing it again. But in the future, we are going to be adding in multiple vectors, which is why we're going to go through this again. We draw our triangle. We have our X in the X direction and our Y in that Y direction, which means now we have to figure out which trig functions to use to solve for each of those. So if I was solving for my Y, what trig function would I use? Sine, because it's going to be opposite over hypotenuse. So we're going to have our Y over that 14 equals sine of our angle, which is 32 degrees. If I was solving for my X, then which trig function would I use?
Cosine.
Cosine, because I have my adjacent or the one next to my angle divided by my hypotenuse next across from the right angle. So X over 14 would equal cosine of 32 degrees. So once we've drawn our triangle, we've determined where the X and the Y are going to be. We're going to use those trig functions to solve for X and Y. So when we solve those, you should get this one right here. If we solve this one, if we do this, we have over, sorry guys. So we multiply our 14 to the other side. So we have x equals 14 cosine of 32. And so x equals, if we do 14 cosine of 32, we get 11.87. And if we solve this one, we're going to multiply that 14 to the other side. We have y equals 14 sine of 32. And if we do 14 sine of 32, we get 7.42. All right. So then if we look up here, how come we have 7.4 and then 12? How come our values are 7.4 and 12 and not 7.42 and 11.87?
Because the x has to be negative in that quadrant.
Perfect. So the first thing, the x is negative because we're going into the second quadrant. Awesome. So this x turns out to be negative. So x is negative 11.87 or negative 12 newtons. But why is it not, why do we round that to 12?
Because of sig figs.
Because of sig figs, our degrees and our magnitude, our direction and our magnitude both have two significant figures. So make sure you're rounding your answer to two significant figures. Are there any questions on what you guys would be doing for a one vector?
No.
All right, should we practice one as a class?
Yeah.
Yeah.
All right, so we're gonna skip page 2, okay? Go all the way to page 3 where our first practice problem will be. So we're gonna calculate those vectors components for x and y. So I'm gonna draw the table just like they have before. So we have our x direction and we have our y direction. Just so we remember, that's what we need to find. And we're finding it for this vector A. So vector A means the arrow above the vector's name. And so the first thing we're going to do is what? What are we going to do with this picture?
The triangle.
Draw a triangle. Perfect. So I'm going to draw my triangle. And I'm going to pretend that looks like a right angle. And I'm going to label my components. Vector A was 12 newtons. We know that our angle was 37 degrees. All right, where's my x?
The bottom.
The bottom, which means this is my y. All right, can anybody tell me how to find x here?
Cosine of 37.
Awesome. So cosine of 37 equals x?
X over 12.
X over 12, good. So then if I wanted x by itself, how do I get x by itself?
Multiply by 12.
Multiply by 12, so I have 12 cosine of 37. And so if we do 12 cosine of 37, oops, we get 9.58 newtons.
Mr. Dembele,
Yep.
my calculator is giving me like 9.2.
All right. So double check that you're not in radians.
How do you double check that?
Do you see your mode button?
Mm-hmm.
All right, click on mode, and then it should be the third thing down. Should say radians or degrees.
Okay.
Just make sure you switch it to radians or to degrees, not radians, because I think radians would give you the other one. Let's double check. Is that what you were getting before? This bottom one?
Yeah, okay, I just switched it. Thank you.
Yep, no problem. All right, so we should get that 9.58 newtons. And then if we do our y, how do we find y?
Cosine of 37 equals 12 over y over 12.
You said which one? Sine or cosine?
Cosine.
Cosine?
I mean, sine.
Sine. There you go. Sine of 37 equals y over 12. Good. So if I wanted y by itself, how do I get rid of that 12?
Multiply it.
Perfect. We multiply it to the other side. So we have 12 sine of 37. And what do we get for our y value here?
7.22.
7.22. Perfect. And we have newtons again. And so now our last step is just going to be to make sure we're in the right quadrant and to make sure we round to our sig figs when we put it in that table. So my x should be a positive or negative?
Positive.
Positive.
Positive. So what should my positive value be if I round to sig figs?
9.6.
9.6 newtons. Perfect. And my y should be positive or negative in this quadrant?
Positive.
Positive.
Positive. And what should I round it to?
7.2.
0.2. Oh, this is meters per second. That would be wrong. My apologies. These should all be meters per second. Wrote it down wrong. Any questions on this one? Or what you would be doing for these types of problems with one vector?
No.
Right, so let's add in some more vectors. So we're going to go back up to page 2 now. So we're going to be solving for the resultant vector of 2 or more vectors interacting. So now we have 2 vectors or 2 magnitudes in 2 different directions. We need to find our components in the x direction and in the y direction for both of these vectors. So if we're doing that, we're going to redraw each of them and find our x and our y for each component. So they took this first one, A, and they made a triangle right here with our angle 74 and our value of 17 newtons. They took the second one and they drew it down here, B. It was 19 degrees off our x-axis, and it had a magnitude of 22 newtons. So the first thing we're going to be doing is determining those sides. Again, your x and your y, which one's your x, which one's your y, and then you're going to be solving for those x and y components. So once you solve for those x and y components, they do them up here for you. We have positive values for both our x and y components in the x direction because we're in quadrant 1. And our values for the x and y for vector B is both negative because we're in quadrant 3. To get the total, what we did was just added these 2 together and added these 2 together. So negative 21 plus 4.7 gives us 16 newtons, and 16 minus the 7.2 newtons gives us 8.8 newtons. Are there any questions on how these were found? All right, so we're not done because what they want us to do afterwards is find the resultant vector, which just means the one vector that adds the 2 of them together. So what we're going to do is we are going to draw the vector from our total, and we're going to draw that. So we're going to go up 8.8, and we're going to go to the left 16 newtons because our x was negative and our y was positive, which means we're in which quadrant?
Second quadrant.
The second quadrant. Perfect. Our last step is going to be to find that angle. And to find that angle, we need to use trig. So we're going to draw our vector here. So you can draw it this way, or you can draw it this way, whichever way works for you. Once you draw your vector, you are going to use the inverse tangent, because if we draw that triangle, wrong one. We draw that triangle. I'm going to draw mine this way. All right, that's my right angle. My X was 8.8 newtons. My Y was 16 newtons. I was looking for this angle. So if I'm looking for that angle, I have my opposite and I have my adjacent. So I'm going to use tangent.
Sorry to interrupt. Isn't x negative 16?
Oh, thank you. Did I flip them?
Yeah.
Thank you so much. So I'm using tangent of my opposite, which is 8.8. Thank you. Over my adjacent, which was 16. And so if I want to find my angle, I take the inverse tangent of that value. Oh. And if I do that, I'm going to get inverse tangent of 8.8 divided by 16. 28.8. But that's 28.8 degrees off of this line, which means that if I'm trying to find my angle from 0, which is the other way, how would I find that angle?
Subtract that from 180.
Subtract it from 180. Perfect. So if I subtract this from 180, I get 151 degrees, which matches up here. Any questions on this or on anything from this demo problem or this example? We're going to go through one together, but I just want to see if there are any questions before we go through one all together. All right, real quick, they did it the opposite way. So they found this angle right here first. Oh, there we go. So they found this angle first, and so their triangle was drawn the opposite way, which is why they added 90. So you just need to figure out where your angle is going to be, and then either you're adding 90 or you're going to subtract from 180. So you have that choice whether or not you want to do 180 minus your value or 90 plus your value. So it is up to you.
I just have one question.
Yes.
Why is 16 positive?
Why is 16 positive right here?
Mm-hmm.
So it's only positive because I am just drawing my magnitude right here, because my direction is going to come from my angle.
Oh, okay, got it. Thank you.
Mm-hmm. Any other questions? We ready to do a practice problem? All right. So our practice problem is on page, I believe this is page 4. We have two vectors, vector A and vector B. So we're going to draw that table just so we know how to set everything up. Vector A and vector B. And we're going to have to find a total at the end for the X component and for the Y component. So we're going to start with A, or do we want to start with B?
A.
A, perfect. So we're going to draw our triangle for A. right, and we have an angle of 24 degrees and a magnitude of 17 meters per second. So where's my x component?
On the bottom.
On the bottom. Where's my y component?
Going vertical.
Going vertical, perfect. How do I find my x here?
X divided by 17 equals 24, or cosine 24.
Perfect. So how do I get x by itself?
Multiply the 17.
X equals 17 cosine of 24. So what does my x equal here?
$15.5.
Perfect. All right. How do I find my y?
Divided by 17 equals sine of 24.
All right. So if I wanted to get y by itself, what would it equal?
Seventeen times sine of 24.
All right. And last but not least, what does my y equal for vector A?
16.9.
Awesome.
I mean, wait, 6.9, I mean.
6.9. All right. All right. So now my last step to put it in my table. Let's round it to sig figs and let's put it positives or negatives depending on their quadrant. So my x, what is it going to be for vector A?
16 meters per second.
And my vector y for vector A?
6.9 meters per second.
Perfect. They're both positives because it's in the first quadrant. All right, we have to do the same thing, but now we have to do it for vector B. So we're going to draw our triangle. Vector B goes down this way. All right, where's my x component for this one?
The bottom.
Bottom. And my y component is where?
On the right side.
On the right side. Perfect. So let's do the same thing. How do I find my x?
Sin of x is equal to 16.
All right, so x is equal to sine of 16.
X divided by 21.
Divided by 21. All right, so how do we get x by itself?
Multiply by 21.
Multiply by 21, so 21 sine of 16. So what does my x equal?
5.78.
5.78. And then my y, how do I find y?
X divided 21 equals cosine of 16.
We're gonna switch that to y divided by 21, right?
Sorry.
No, you're good. Just want to make sure. All right, so how do we get y by itself?
Multiply by 21.
By 21, cosine of 16. And what is my y value here?
20.2.
You said 8.52?
20.2.
20.2. 1.2. All right. So now let's put it into our table, including our positive or negative signs depending on the quadrant. So what am I putting in for my x component for vector A?
Negative 5.8.
Negative 5.8. And what is my y component for vector B?
Negative 20.
20 meters per second. All right. So now to find my total, I'm going to take my x component for vector A plus my x component for vector B. So what is 16 plus negative 5.8 meters per second? Remember to round to our significant figures.
It would be 10.
It would be 10 meters per second. Awesome. And then my y component, we're going to add vector A and vector B.
Negative 13.
Negative 13 meters per second. Awesome. So now which quadrant would my resultant vector or my total vector be in?
Quadrant 4.
Third.
All right, I heard quadrant 4. Did anybody say anything different? Anybody agree? I'm assuming that everyone has agreed because nobody said anything different, and that would be correct. We're going to be in quadrant 4 over here at 13 and negative 13 meters per second down and 10 meters per second to the right. All right, we have to find our magnitude of that vector, and we need to find the angle for that vector. Which one will we want to do first? Magnitude or direction?
Magnitude.
Magnitude. All right, so let's draw ourselves a triangle. Which type of triangle would we like to draw? Do I want my y?
Right triangle.
A right triangle. Do I want my y going over here or my y going over here? Up to you.
The first one.
First one. All right, I heard that one first. So we're going to draw our triangle. We have our resultant vector. If you want to label it a letter, that's fine. Usually would go with C. What's my y going to be? Heard someone start to say it.
Negative
Negative
13.
13.
13.
13. And what's my x?
10.
10. Where does my angle go? And 1, 2, or 3?
3.
3.
Here, lots of 3. So I'll put my angle right here. Everybody agree? Anybody disagree? All right. So if we're finding you guys said magnitude first, right? How am I going to find this resultant vector? I'm going to call it C. How am I going to find C?
13 squared plus 10 squared.
Pythagorean theorem.
Pythagorean theorem. Perfect. 13 squared plus 10 squared equals C squared. So if I do 13 squared, what do I get?
169.
169 plus 10 squared, which is
100.
100 equals C squared. So my C squared is going to equal a total of
269.
269. And if I find C, what is my value?
16.4.
I heard 16.4.
Mhm.
All right. My angle. How do I find my angle?
Inverse tangent.
Inverse tangent, perfect. So the inverse tangent is going to equal theta. An inverse tangent of what divided by what?
13/10.
13/10. And what do I get for my angle if I do the inverse tangent of 13/10?
52.4.
52.4 degrees. All right. So if I'm drawing that on here, where would that 52.4 degrees go? Any ideas? Or let's put it in here. So this theta equal 52.4. All right. So now if I'm putting that on my triangle, where am I going to put that? If I'm putting it back on the graph. Any ideas?
Next to the 16.
Huh?
Yeah,
Next to 16?
across the 16.
Across. So
Mhm.
can you draw it on yours? So if you open up Zoom on yours and pull out your pen, draw it. You should be able to, hopefully.
I'm not on my tablet.
Oh, okay. So am I putting it here at 1, here at 2, or
Yeah.
somewhere else?
Yeah, those.
Which one?
1.
At 1?
Yeah.
All right. So this is my 52.4. Everybody agree? Anybody disagree? I'm going to disagree. Because if I were to draw my triangle on this graph, if I were drawing it right here, this is where my triangle would be. This was my 13. This was my 10. So where did my angle go?
On the first one,
Where?
the top one,
Over here.
yeah.
Let's look at our picture. Let's look at the triangle that we drew. Is that where the angle we put?
Oh no, it's on the third one.
All right. So we're going to have to move it way over here at 52.4. So you got two options here. We know that this is 90, which means that we can do 90 minus 52.4 to find this angle right here. The other way is because this line right there is parallel to this line, we know that this angle is going to equal this angle, which means our 52.4 degrees goes there.
So you subtract it from 180.
So we subtract it from 180. If we're trying to start at 0 and we try and find the angle that goes from here all the way to here,
Oh, 360.
we'd have to subtract it from 360 to get to this angle. So our resultant angle is going to be that 360 minus 52.4, which gives me what?
$307.6.
All right. So now I'm going to total everything up. My resultant, my magnitude was 16 meters per second at an angle which was 308 degrees. Any questions on this one?
How do we know which angle we're supposed to find?
So that is up to you which angle you want to pick, but always, you really always want your angles to be up here. So either draw the angle, if you're drawing this triangle, you want your angle to be the one that's closest to the X or Y axis. So when you drew your triangle, you want to figure out what your triangle would do if we matched it up with our graph. And we always want to find the triangle, find the angle that matches up with our graph. You know, the
I
X.
mean, like the resultant angle, like our final answer. Like, how do we know that if we have to do it by 360 degrees?
So you're always going from 0 degrees. So then you have to figure out, I'm gonna erase all this real quick. So you're always going from 0. So if you're starting at 0, we have to keep working our way until we get to our number. So you can either take 270 and add whatever angle you got for your angle up here, because it's 270 is this y-axis, plus whatever you got to get your angle for the resultant. Or if your angle is over here, that means you're this much away, you're theta degrees away from getting back to 360. So you're going to subtract 360 minus that angle.
So you always go counterclockwise.
Always go counterclockwise.
Okay.
Is everybody okay with that? All right, guys, then you have today and tomorrow to work on these practice problems. There are 7 more, right? Yep, 7 more. 3 more with just 1 vector and 4 more with 2 or more vector components. If you guys have any questions, let me know. Have a good rest of your day.
Thank you. Have a great day.
Thank you. Bye.
Bye, Mrs. Belly.
Yeah.